Journal of Bahamian Studies, which is the University of the Bahamas, open access research journal. Yes, I am assisted by the previous managing editor and current associate editor, Virginia Balance from the library. We're a great team. I'm very happy to, today is the launch of issue 1 of volume 29 of the International Journal of Bahamian Studies, a special issue focusing on science research, natural science research. And we're doing it this week, as we always do, because this is part of International Open Access Week. We're an open access journal. That means that the information is freely available for anyone around the world to download. It's not behind a paywall. If you're familiar with the journal, you'll know that in the past we have almost exclusively published social science and humanities research. And so the editorial team, we were really excited by the fact that this year we got a good number of high quality natural science manuscripts focusing on the Bahamas. And so that's why we decided to have this special issue launch, have a special issue focusing on natural science articles, and to have the launch be for the natural science issue. The remainder of the articles will be published in issue 2 of volume 29, which will be released in a few weeks, and it'll have 10 more articles about 10 more great articles of Bahamian original research by scholars at UB and abroad. So we are fortunate enough to have 2 of the authors for the articles present here today. I believe 2 other ones will be joining us by Zoom in the next few minutes. We have 5 articles today. And so I'd like to start us off with Dr. Williamson Gustav, who has been working with a couple teams of students and faculty. It's great that he's gotten his students and faculty to collaborate on research, and I think that's really great. So he's got 2 articles that he's collaborated with students and faculty that he's going to talk about today. I guess I should say that the journal is available as a link on the main UB webpage. So if you just go to ub.edu.bs and then go research here, the International Journal of Bahamian Studies, that will bring up the website. It's all available right now. So Dr. Gustav is going to come up and talk about his 2 articles that he produced in collaboration with students and faculty. And he's going to start with comparative analysis of soil health in backyard farms on multiple islands of the Bahamas. Okay. Okay, there we go.
Good morning, everyone. Thank you, Professor Wember, and thank you all for inviting me. So I want to first start off that a lot of this work and more to come is being done by our lab, which is a soil and complex matrix lab that is currently housed at the Small Island Sustainability Complex, and with the sole aim on characterizing the soil physiochemical and biological property of our Bahamian soils. So this first article here was led by one of my Bio 480, 490 students as their final project, Devin Chambers. He's currently not here, and I'm sure he'd have been giving a better presentation than me on his work, but he is in medical school, unfortunately, because I think he would have made an amazing soil scientist, because he's very, very passionate about the field. And he spent numerous summers collecting the data and putting the work. And this work was supported by the graduate school, which is currently led by Dean Romelda Moxie, small fund that we got from it. And this work, what we did is, there's this idea that at some point, the Bahamas is going to mysteriously and immediately begin to feed itself. And the government is heavily investing in promoting that we should start small backyard farms, or start, we call them small stakeholder farms, and try to provide some of our own foods. But there's a problem with this idea, because as you all are very well aware of, you are not going to have any appreciable yield in your food if your soil quality is not up to standard. And very little effort has been put into soil research. It's an area that is heavily neglected, and it's one that we all cannot live without. In fact, without soils, we all would be dead, not only from hunger, but most of the antibiotics on a lot of the ecological services that the soil offer is very essential for life. So what we did is we wanted to, one, examine different backyard soils from across the Bahamas, and then we wanted to two, report the status, three, compare the status of these soils with the standards that are available, and then three, offer some solutions or some advice on what these farmers can do. So as you are all very well aware, it's very difficult to do an experiment that accommodate the whole 14 inhabited islands. So what we did, we went on Facebook, we found small groups where farmers would communicate, and then we offered them a deal that they cannot refuse. And the deal was, if you mail us a sample, we'll pay for the freight, and in return, we will give you an analysis of your soil, and we'll also offer expert advice on what can be done to the soil to make sure that you are getting optimum use of your soil. So by this effort, we were able to collect soil from at least 8 different islands, including New Providence, Exuma, Ragged Island, Eleuthera, and a couple of other islands. And then we measure both the physical, the chemical, and some biological properties of the soils. And after measuring these properties, we compare our results to the standards, and then we class the soil whether or not it met the standard to be said it's healthy, and if it didn't meet the standard to be healthy. In addition to that, we also interviewed those individual small stakeholder farmers, and we asked them on the practices that happens on their farm. Do you fertilize? And if you fertilize, are you using synthetic fertilizer, or are you using organic fertilizers? So our results, from all of the 38 samples that we collected, none of them, it's not funny, it's actually sad, because now we're encouraging you to invest money in getting seeds, and your soils are not to par to provide the nutrients and to provide the appropriate condition that is required for you to have an appreciable yield for what you're putting in there. None of the 38 samples met all of the criteria that is needed for plant growth. Although different samples would have met 1 or 2 or 3, but none of them met what would we have. We have a checklist. If you are to be healthy, you need to have this amount, that amount up. None of them were able to meet that. We also compare whether, if a farmer is using synthetic fertilizer, no fertilizer, or organic fertilizer. We found that regardless if you add in synthetic fertilizers, based on the time that we got the sample, there's actually no different in the nutrients availability, which is kind of expected because the soils here has very low, what we call cation exchange capacity. basically means that the soil is not going to retain anything you put in it. So you can invest tons of dollars in fertilizing your farms, but after a good rain, farmers pray for rain, but after that rain, all of the fertilizer that you actually added is going to be washed away. And then some of the nutrients, for example, like phosphate, because our soil conditions and our pH of our soil is so high. And under such condition, phosphates will be tightly bound on soil minerals. So even though the phosphate is in the soil, the total phosphate is high, but the bioavailable phosphates, which is the phosphate that the plant can actually use, was very low, and which means it's no use for the plant. But we did find some good news, and we did find some good finding, is that farmers who use organic fertilizers like animal dung, composting, those farms, although they are not to be classified as healthy soils, but they are much better than those who use synthetic fertilizers. And those farms had more bioavailable nutrients as compared to the one that used synthetic fertilizers. And the reason for that is quite simple, right? If you add organic matter into the soil, you're going to have the release of these nutrients in stepwise manner as the microbes that live in the soil break down this. So you don't have a huge release and then none. You have it over time. And then organic matter is very good at augmenting soil pH. So it kind of decreases the soil pH, at least in the area or the vicinity where it is. And then that will help to improve the cation exchange capacity. So you'll have better and more controlled release of the nutrients for the plant. We ended this article by offering advice to the farmers, and also advocating that if we are truly serious about feeding ourselves, then we need to invest more time and energy, like every other agricultural-based country, in our soils. Because yes, hydroponics would work, but hydroponic has a very high overhead cost, and it's going to, and you guys can see it if you go to certain food stores and you look at the locally grown vegetables, and I'm not going to call the farm name, and you look at the price of it, it's almost 3-4 times rather than the one that grows in the soil. And that's for a reason, because it's you spend a lot more energy, time, and money to grow stuff hydroponically. That's it for the first article. I'll stop there, and if you guys have any questions, any concerns, I'll be more than happy to address them before we move on to the next one. Go ahead, Professor Curley. I'm just trying to be like you all. Yes. Uh-huh. 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 Yeah, less than 20 centimeters. Yes. Yes. I am mentally taking note of that. Okay, I'll try to answer those questions. Let me see how good my memory is. Yes, we did have a sample from Andres, and contrary to popular belief, samples from Andres, at least the one we have, is no different from samples from New Providence and elsewhere. Yes, it has a different color, right? But in terms of nutrients, and that's probably because in Andres, they have been farming for a while, and when you add synthetic fertilizers over a long period of time, it damages the soil. And probably now we are reaching to the point where the soil is no longer at its peak in Andres, even if it started that way. In terms of why we have a thin layer of soils, our islands are very, very young, and they are limestone-based islands. Yes, you can add organic matter, but it would take thousands of years to add a little bit. And most importantly is our practices here. Anyone who purchases a piece of property and is going to build a home, the first thing we do culturally is get a bulldozer and remove the living layer of the soil. Then we build our home there, then we take thousands of dollars, and then we buy the dead curry, and we put it over in our yard. And then mysteriously, we expecting now grass to grow on that. I never understood, and that's one of the things that drove me into soil science and studying agriculture, why we do this. We bulldoze and throw away the living part of the soil, then we purchase dead soil, and then we try to grow our plants on it. So, and in terms of the plastic, plastics are actually very bad. And in fact, new studies are showing that plastics are producing a lot of microplastic and nanoplastics. And these microplastic and nanoplastics can enter into our crops. Recent studies show fruits, like tomato fruits, that were grown in farms that traditionally applied plastic mulch to prevent weed growth, are all contaminated with these microplastics. And cell-based culture studies show that these microplastics can cross over the plasma membrane of the cell. And I think with more studies, we'll now find out that they can interfere and detect with cellular activity. And very soon, I'm just predicting it, it's going to be linked to cancer. Yes. Yeah. Uh-huh. No, this is true, Professor Carolyn. This is definitely true, but you have to understand that the channels in the rhizosphere are not, those receptors are not as specific as we believe. So as long as the chemical properties are close enough, it will let it through. For example, during my PhD, I studied rice and arsenic and how microbes make arsenic available in the soil. Arsenic is going to enter the plants through silica channels in the root and aquaporins in the root. And it's able to do that because it just shares very similar chemical properties of these needed nutrients and minerals, and it goes through. And I think the same thing. In fact, the cell membrane will allow anything that is non-polar to go through very easily. That's why, air and small molecules are able to go through. And then the cell membrane has many channels that act as they're transmembrane proteins that, for lack of a better word, are not very good at discriminating what they let through and out. And especially with micro and nanoplastic, sometimes they attach on the surface of these nutrients and make it inside the cell. So it's a very complex situation. We just have to learn and see what it costs. In fact, there's a paper that talks about when you make a cup of tea bag, you're drinking trillions of nano and microplastic with that, because the material they are making the tea bag thing is, it contains plastic in it. Not per se, not exactly. It's just small at the same size, but not just the one atom. Yes. Yeah. Go, sorry.
So do you think that traditionally agricultural development, do you think it's just because of history that agricultural development in the Bahamas is largely focused on Andros? Like, it's a stereotype or something like that? Or?
I think it's because of the geology of that island. Unlike other, like New Providence, where we have very, very thin layers of soil, because Andros has so many freshwater marshes, so you have buildup of sediments in a lot of different areas, and so they have a thicker layer of soil. And then the soil type and the soil color in Andros, once we see dark soil, we automatically associate that as being rich. And then they have less development, so there's more space to have these farms. And then it's very easy to get crown land in Andros. So if you want to make a farm, you go there. Yeah. That's,
What would be the implications for, say, fancy?
with that,
Wasting their time.
I wouldn't say they are wasting their time. I would just say that they should practice, and and I'm not saying that they are not doing it, they should consider more sustainable methods that can be translated and passed on to those small stakeholder farm holders, like the backyard farmers. But I wouldn't say they are wasting their time. But I do feel that from what I've seen and looking at, they may be heavily using fertilizers.
Which is not what you're recommending.
No, because then you're gonna, especially if you, all fertilizers, one of the key thing is you gotta make sure it can dissolve when they get in the soil. To do that, we normally produce fertilizers as salt. So when the salt dissolves, the ions that increase salinity of the soil, the plants are not gonna use it, it remains, and over time it builds up. And then when you add so many nitrogen-based fertilizers in the soil, you will off-balance the nitrogen to carbon ratio of the soil, and then that will cause a lot of issues as well too, because now the microbes are going to try to balance this ratio, and to do that, they're gonna break down organic matter at a much faster rate, and it speeds up deteriorating soil quality. Yes. I think that takes a tool too, but I think the first step is that instead of copying and pasting what industrial countries have done, we should try to develop our own sustainable methods where in the long term, the next 2 or 3 generations will begin to benefit rather than rushing and without even learning from the mistakes. I'm sure you guys are very familiar with the Dust Bowl in the United States. And I think if we continue in the path that we are going, we are heading in that direction, we'll have our own Dust Bowl.
Okay, we have one more question from
Dr. Kabir.
Kabir has a question. And then we'll move on to the next
Would you
article.
say that the soil of color of Andros and Nassau is different?
Yes, in Andros, they have more organic matter in their soil, and it has a very dark, rich color. As compared in New Providence, because our soil layer is so low, and then what we normally do, because when you first build your home, you bring a lot of the curry, we call it here, but it's just calcium carbonate rocks, and then we mix it with soils that we go into the food store and purchase, so the color is very light, and the soil in Andros have very good texture, so it has aggregates, because it's being undisturbed, as compared to our soil here, where we just put there, so it don't really have texture, it don't have real aggregates. So that's why when it rains, if you look very carefully, the water is very muddy. And if you look at your backyard over time, all of your soil is gone because it has no structure, no aggregate to keep it in place.
Okay, let's move on to the next article.
Okay.
Led by Dr. Gustav. That was fascinating. Thank you to Dr. Davis and Dr. Toppin for joining us, honoring us with your presence. Okay. This one. Stubs. All right. Let's keep going.
Okay. So, like I explained earlier, in our lab, we focus heavily on soil and complex matrix. So, after Hurricane Dorian, there was this a lot of energy being placed on restoration, and a lot of efforts were being placed on things that people can actually see. So, for example, a lot of efforts and a lot of attention was given to the pine forest and the destruction of different habitat, but very few people focus on what's been happening in the soil. And like I explained in the first paper, if your soils are not in good condition, it's like your home. If your wife is not happy, that house is not going to be a happy house, right? So if your soils are not in good condition, you can bring as much as new seedlings as you wish. These seedlings are never going to establish, and you're never going to have any reforestation or regeneration of that ecosystem. So, and that same year, and I was fortunate that year to have so many brilliant 480, 490 students. Danica Stubbs worked with me, and we were fortunate enough to get some residual funds from another grant that was already going on in Grand Bahama. And we traveled, they offered us the opportunity to travel to Grand Bahama. And we traveled to Wellfield 1 and Wellfield 6 in Grand Bahama. And we chose those two sites because Wellfield 1 and Wellfield 6 are major freshwater reserve wells in Grand Bahama. And after Hurricane Dorian, those wells were contaminated. So the water in Grand Bahama was all salt, very, very high in salt concentration. So we decided that we are going to measure soil samples and build upon two previous studies that was done in that area, in that same site. So in this experiment, we assessed the soil salinity on Grand Bahama post-Dorian, 3 years after Dorian, in Wellfield 1 and in Wellfield 6, which build on two previously published articles, one that took the soil samples immediately after Dorian, another one a year after Dorian, and this one we're doing it 3 years after Dorian to see if the soil conditions have returned to somewhat normal. And we still are doing more work on soils in Grand Bahama, and at a later date, you will see the fruits from that project. So we went to Wellfield 1 and to Wellfield 6. We collected soil samples, and we decided that we're going to take these other publications one step further. In addition to measuring salinity, we went on and measured soil health indicators because these well fields are also located in pine forests. And our measurements, our results show that the soil salinity, it's almost the same as what was previously reported post-Dorian. And we try to understand why that was able to happen. Well, when you look at the soil texture, in the beginning, why the soil salinity in these areas was very high, the flooding that happens during Dorian brought in a lot of silt, a lot of clay material. These clay materials have very fine particles that are tightly packed with one another. So when they settle in an area, they actually close and prevent water from going through to flush out of the soil. So the first year it was high because of that. But the second year, and by the time we did our sample, most of that clay material has already been washed away. So we left with our regular Bahamian sandy soils that has very thick soil particles that leaves very big spaces in between. So, and of course in Grand Bahama has lots more rain. So a lot of that soil salt that was once stored and built up in the soil has now begun to get washed away. And that would explain why we have the decrease in the soil salinity to almost now normal. We also measured the nutrients content of the soil. Of course, Grand Bahama, just like in New Providence, their soil nutrients is very depleted. But I wouldn't say depleted because it was never there. It's very low because it's limestone mostly, right? And the organic matter content is also very, very, very low. And we advocate at the end of this to continue to monitor this area because this is going to play a very important role in the conditions that the freshwater lands would be. Because as long as the soils remain with high salt concentration, then the freshwater lands is going to take a while before they return to being fresh. And we also advocate that we should plant, rather than bring in plants from elsewhere, wait until you have regrowth and then use those plants because those plants would have adapted for that particular condition. Because if you go on a different island where the conditions are a bit different and you bring these plants to Grand Bahama, those plants are not going to be successful. You are going to have lots of issue with the reforestation. And that's it for this paper. Any questions, concerns? Dr. Topic?
Good morning.
Good morning.
While this question may not necessarily be directly relevant, I've noticed over the years that in the Bahamas, whenever, especially the province, whenever they want to do landscaping, etc., they bring in, they import
Soil.
soil and also foreign plants. And I noticed that they neglect to plant any national flowers, the yellow elder.
Uh-huh.
Right? Do you know how well the yellow elder grows in our soil? And wouldn't it be a good idea to, instead of bringing in all the flowers and stuff,
The plant that? I think that the yellow elder and any native plant will definitely respond and do much better than any imported plants. And you would see, especially if you drive around Bahama Avenue and Albany area, you would see, if you were really paying attention, every other month they're actually replacing almost all of these plants, because the plants are just not the conditions are not just suitable for it. Or you would see they are heavily fertilizing and replenishing the nutrients. So it would be a very good idea to plant native and local plants rather than doing the imported plants. I don't know if you're familiar with it's a grass. It doesn't grow like the regular grass that we have out here. It looks like a rug instead. Yeah, it grows like a rug. That grass will do very well here. Don't care how much you cut it. In a day, it returns because it have adapted and it has adjusted to grow in a shallow, poor nutrient soil. But then it's not appealing. So people would prefer the soil instead, and they bring a lot of it here. So it would make sense to plant local and native plants and wait. Ecosystems have resilience. They are going to bounce back. Just give them enough time, and then you would see the type of plants and seedlings that are coming back, and then you just propagate those ones, and it will be, your chance of success will be much, much higher. Thank you, Dr. Dolphin.
You said during the hurricane trade patterns brought in.
Yes.
Where did they come from?
The sediment, the ocean sediment. A lot of sediment, especially near the mangroves, would have came over. Yes. So you have this, if you look at the pictures from the water, it looks very milky. And then when it settles, all of the clay that caused the milkiness and the turbidity is what left the particles behind. Go ahead. Mm-hmm. Not exactly. In Florida, they have done a lot of things to change their soil. If you look at Florida, when you come in it, they have dredged to bring lots of fresh water in, one. Their geology is not exactly the same. And then they have the Everglades with a whole bunch of rich nutrients that can come in. Uh-huh. Uh-huh. Yes.
And then they cut off all the land, the green flourishing limbs, expect the tree to survive.
Yeah, they're probably doing that because you see, in these other places, these roots can anchor 2-3 meters down. Ours are probably just spread all over. So whenever there's a big wind, if they don't get rid of the leaves, they're not going to be aligned to Tonic William Darling Highway. They're going to be across Tonic William Darling Highway. It does, but you can cut some of them, and that's gonna, so the wind don't blow them down. Yeah, I guess. Yes. Yes.
That's why they should propagate the yellow elder.
Yeah.
It is our national flower. How many places do you go where you actually see yellow elder? I see a lot more bromeliads and palm trees than yellow elder.
Any other questions, comment? Okay.
Okay,
Thank
great.
you.
Thank you so much, Dr. Gustavo.
You're welcome.
And someone needs to tell the Norfolk Island pine that I wanted a Christmas party 7 years ago. That was about this tall and planted right next to my house. That they're from like the South Pacific. That foreign plants, don't grow well here because it's now 30 feet tall, and it's way too close to the house. But it's such a beautiful tree, I can't bring myself to cut it down. Anyway, okay. All right. Because it was like a little Christmas tree, and then okay. All right. Thank you so much, Dr. Gustavo. Okay. Dr. Kabir is going to present his paper, A Study of Atmospheric Aerosols in the Bahamas Using Camera, LiDAR, and Star Photometry Techniques. Photometry. Whatever, you can pronounce it. Yes, exactly. All right.
Good morning, all. And thank you, Dr. Onbring, for accepting my paper, publishing it in IGBS. I must tell that I was impressed about the review process and the editing of my journal paper. When I submitted and the final product has a lot of difference, it was very impressive.
Good. I will say that finding reviewers for natural science articles proved to be the hardest of all yet.
I know.
Anyway.
A little bit too hard, I think.
Yes.
I understand that, yeah.
Like, you want someone who's expert in the field, but experts are too busy, and there's no there's no glory in reviewing. So.
Yeah. All right.
Someone in the waiting room. Okay, let's let Dr. Welsh in here. Good morning, Dr. Welsh. Can you hear us?
Yes, I can.
Oh, but you're not on. Okay, yeah, I remember this from last year. Okay, Dr. Kabir is presenting right now. Yeah, okay.
All right, so I should talk about the background of this project. So the title is The Study of Atmospheric Aerosols in the Bahamas Using Camera, LiDAR, and Star Photometry Techniques. So this is the result of many of our papers that I initiated in 2016 after I got several grants from UB Research Grant. So thanks to them for supporting me. And as you see, there are a couple of collaborations in this project. One is University of Central Connecticut State University. There is a professor who I met in one of the international conference. And then we built up the collaboration since 2016, and it's ongoing. And also a research scientist, Dr. John Burns from National Oceanic and Atmospheric Administration. Several students from UB and also from Central Connecticut State University participated in this project. I guess 15, 16 students already participated along the way since 2016 to 2023. We studied aerosols in the atmosphere. So aerosols is a particulate matters, and a very widely studied topic internationally because of their effect in the radiation budget, like how much radiation is going to come to the Earth, how much will be absorbed, and which is directly related to the climate change and environmental study. So one of the biggest problem of study aerosols is they are very changing. They can change location to location. They can change time to time. And that's why there are several techniques to study the aerosols. One of the technique is ground-based, which you can measure only the ground-based particulate matters. But the problem is we also need information from the height-based, altitude-based. And for that, we use remote sensing. So one is ground-based remote sensing, another is satellite-based remote sensing, and also airborne devices. But many of those remote sensing techniques are extremely expensive. And in this teaching-based institute, we cannot afford that expense, like say about 100K for those instruments, which is called LiDAR, light detection and ranging. So what I have used here in collaboration with Central Connecticut State University and NOAA, that we used a laser, which is just $5,000, and a camera, which is $2,000, and a computer. So in total, the project cost $10,000. But yet, that could give us a lot of information, like how much particulate matters at different altitude. So first, we found, it's called aerosol extinction. Aerosol extinction means when light traveling through the atmosphere, because of the presence of the particulate matters or the pollutions, which is originated mainly from local or can be long-range transport like Saharan dust, we can measure those concentration at different altitude. So those are called aerosol extinction again. So that's what we measured using our camera laser technique, which we called CLIDAR. But as I said, the measurement uncertainty is really a huge of this aerosol extinction because of their too much movement, because of the many other factors that can affect that concentration level. So we need not just one technique, we need several techniques to compare those measurements. So what we have done in this study is we measured aerosol extinction and another topic called, another parameter called aerosol optical depth using the same system, which we call camera LiDAR, but then we also use photometric, star photometry techniques. So star photometry techniques means star has intensity, but when they come through the atmosphere, they lose their intensity because of the presence of the aerosols. So if we can measure the intensity at the ground level and we know the intensity, original intensity of the stars, then we'll be able to know how much aerosols are there through the entire atmosphere. And then we can compare the two techniques, like the LiDAR techniques and the star photometry techniques, and we can see that how good the techniques are and how comparable the measurements are. So I'd just like to give you a little bit of background of the technique that we have used. So as you see in the left diagram, a laser is shooted vertically into the sky. So I've done this measurement at the back of the SIS building. It's a green laser. It's a visually stunning laser. We can see it at night very nicely. And when the laser goes all the way to the zenith, it scatters off from the particulate matters, the aerosols, and also from the molecular gases like oxygen and nitrogens. And they come to the camera. So as you see that the camera is placed on the ground and the laser is also placed at the ground, but they are separated by a distance, and that geometry is called biostatic geometry. So when the laser scatters, they are coming to the camera, and we can find how much intensity from the pixel information of the camera. And from one shot, as you see that from one shot, we can really get pixel intensity from all altitudes. And that pixel intensity is basically related to the amount of the particulate concentration in the atmosphere. The raw data looks like on the right side. So that's basically raw data. That's what the data we have analyzed. So as you see that, that's the laser, a stick is a laser. So the bottom one is the ground, and the top is the zenith. How far the laser goes? It goes infinity, but we can measure very efficiently up to 5 kilometers because above that the resolution of our setup goes low, and we don't anymore trust the value. But the good thing is most of the aerosols, the pollutions, remain within 4 to 5 kilometers in the atmosphere, and that is called atmospheric boundary layer. You also see that at the same image we have stars. Since we get the stars at the same image, we can utilize the information of the star intensity and to calculate the aerosol optical depth. So the aerosol optical depth is actually the sum of extinction from all altitude for that entire atmosphere. So this is one of the data that we have got, and that's basically altitude-based aerosol extinction. As we see, above 3 kilometers, there is no aerosol concentration. So in Bahamas, the atmospheric boundary layer remains up to 3 kilometers, means all of the pollutions actually within 3 kilometers. In most cases, in many years that I have done experiment, I have seen that the aerosol concentration remain within the 3 kilometers, the amount of aerosols. However, during the Saharan dust transport in 2020 during pandemic, we have seen a difference of aerosol air, which is beyond 3 kilometers, which is one of the paper that I also published before. That's the picture of the technique that we have used, the star photometry technique. So we have used 2 star technique. So we found the aerosol, the star intensity from a catalog, which is called Bright Star Catalog, which is available and is one of the Russian website that has a list of intensity of the stars. So we need that intensity, the original intensity, and then we can find the intensity for the same camera that we have used in our laser radar technique. And we need to know the elevation angle, we need to know the air mass, and with this information and a couple of equations that we have presented here, we can find the aerosol optical depth there. So this is one of the picture. We have to find how much really is the intensity, which is at the ground level, which is measured by the camera. So this is called Gaussian function. The area under the curve is going to give us the actual intensity that we received at the camera. So there are a couple of calculations, the pair of stars that I have used to find the aerosol optical depth. But I'm going to just give you the result that I get. So we get the aerosol optical depth 0.04, and the uncertainty is also plus minus 0.04. So 0.04 means it's just a 4% of the total radiation that is coming to the atmosphere all the way. Now 0.04 aerosol optical depth is considered a clean air. And 0.1 is 0.04 is very clean air, 0.1 is kind of clean air, and above 0.4 is extremely hazy condition. So we also compared the aerosol optical depth by a satellite-based technique, which is called MODIS aqua satellite, moderate resolution infrared spectroradiometer. The problem is the satellite cannot really cover entire region. As you see that I have the highlighted square there. Not all region can be covered. So we can kind of see that close to Nassau, the MODIS satellite instrument, the aerosol optical depth that we can assume from the MODIS satellite is 0.015 to 1.15. So that range is the value that we get from our technique ranges within that, falls within that range. Okay, so that's basically all we have done. So we have done altitude-based aerosol extinction, and then we also calculated aerosol optical depth, which is the sum of all aerosol extinction for the entire atmosphere. We also have integrated our aerosol extinction from the CLIDAR instruments, CLIDAR-based measurements, and we have seen that that also agrees with all the data. So this is the first time actually we have done, we have shown the aerosol extinction as well as aerosol optical depth from the same instrument, which is not ever done yet by any group. By the way, the technique that we have that we are using now is just done by 4 groups now in the whole world. 2 of them are from China, and 1 in USA, and 1 here. Okay, so yeah, that's all from my side. Questions are welcome. Sure. Ready to answer?
He's very used to that.
Yeah, I'm very used to, yeah, after.
Before digital cameras, you couldn't do this kind of research because you're measuring the intensity of the light.
Right.
So you couldn't, how would
A very good question. Before digital cameras, you couldn't do that. The camera that we use is called charge-coupled device camera. It's a little bit different than the digital camera, but still digital camera can be used to do the experiment. I've seen some groups started doing digital camera also, but we have used charge-coupled device camera. Okay, this is great question. Before that, people used to use other kind of a detector. Okay, like it's called some other sensors, you know. Okay.
So in effect, you are using modern, like the latest technology,
Right.
to do something that it seems to me is complicated calculations.
Right, completely. I mean, of course, I just shown you the calculation there, but I explained everything how it's being calculated. Yeah.
But you can do it.
Yeah. Mm-hmm.
It's something you can do.
What
You
you?
have the right piece of equipment. Like you were saying, you didn't have the most expensive.
No. Most expensive, no. That's the point nowadays, because you see that there is a great controversy nowadays that people are using too much money to do research, but the end product is not like really helping. I mean, of course, it helps, but people are more encouraged nowadays to use small fund to do this kind of a research, which is very helpful. So the thing is, you see that like $100,000, $200,000 people are doing, but how many groups can afford that one? But for a research like climate change, you really need a lot of data from entire region, like from here, from, when I research, I see that this is not done, I mean, only Barbados is doing this atmospheric like remote sensing research, but not in the entire region. Even not West Indies is not doing that much. Like Jamaica, they have universities, they are not doing that. Puerto Rico and Barbados, those are the two, but those are also led by USA. Okay, so, but it is highly encouraged that we have data from locally to really predict climate change, because this information is really necessary, that we have all information. And as I said, because of that high expensive instrumentation, I mean, most groups, think about Asia or Africa, they cannot afford that one. But like $10,000, $15,000 is pretty affordable. And if we have a lot of data from around the world, that's really gonna change the whole thing. Yeah, community-based science or citizen science, really. I mean, I would say $10,000 is nothing, you know that, in physics. People get grant for $1 million.
It's sort of more sophisticated, what you do.
Right.
More sophisticated than people who collect, measure the rainwater levels.
Right.
Which is also important.
Of course, which is also important.
For
Yeah.
climate change to measure.
Yeah.
To have data over a long time series from many different spots.
Now the thing is, of course, now I need another laser, because the laser I'm using for last 6 years, so they have gone down now. So that's what I realized. So now I need another laser 5. I mean, see that one laser I have produced so many, I think so many papers, publications I have done in last 6 years. And that was wonderful, I think. And when I started, I never thought of that. That's gonna give me so much paper or publications. I mean, I didn't have any idea, because I met that person. She asked me, are you interested? If you're interested, because I had a laser background. So she told me, okay, you can do that. So okay, let's go. And then I met with that guy, Noah, and he basically, I mean, I even visited actually Central Connecticut State University from my own pocket, you know, from expense. So. Yeah, it's like, you know that in atmosphere we have like aerosols. And that, what are really aerosols? It can be originated from the local, like burning, you know, anything, trash, you know, ocean, you know, breaking waves, volcanic eruptions, so many things. And also like Saharan dust and Asian dust all over, okay, so. It's called atmospheric boundary layer, ABL. Yeah, like California and, you know, Hawaii, those places, because of the volcanic eruptions, they are very far, like 5-6 kilometers. So their boundary layer is much higher than in Nassau. Nassau is relatively much cleaner. That is the pollution, because the pollution, the wind effect, several factors are there. Yeah. Right. But the thing is, more is the aerosol extinction, more is the pollution at that place. And more is the aerosol optical depth, of course, that's also more. So aerosol optical depth, more means light is not coming much through the atmosphere. So they are blocked by the pollution. Okay. Like I went to San Salvador, actually, did my experiment. When I went there, the stars are so clear, you can clearly see that one. I also published that paper, and it's just beautiful stars there. You can clearly see the aerosol extinction is really low. I get here 0.04, something like that. I would say, I think it was 0.01 or something like that. Okay, it's almost 3 times lower than here. Okay.
This is more of a comment.
Sure.
You know, as you know, everyone who does research at UB, we were faced with the realities of not having the same resources as universities in the north. And you know, I often console myself with, well, at least I'm not in physics, you know, because you know they need like lasers and And like really expensive.
Is that expensive?
Basic research, you need extremely expensive technology to, this isn't exactly my research program, but a lot of English research is just analyzing books. That's all you need is the book or the poem and something like that. So that's not that expensive.
But you were right. Like my background is when I mean with lasers and those things, and I used to work in $1 million group, right? At the research lab. All the lasers are $300,000. And when I came here in the Bahamas, I wrote my first proposal, which was $200,000 thing. So I had no idea because I was not told about the whole thing. I had an expression that I'm going to get a seed fund, a good amount. I'm going to well, I realized that one soon that no, I'm not going to get that. That's impossible. I wrote that proposal with some other colleagues. But after 1 year, I realized it's not going to happen. Clearly not. So then I had to think the other way around.
I commend you for your creativity and hard work.
Thank you. Yeah, but again, I told you, I really got a lot of support. The first grant I got, Dr. Davis was there, probably she remembers. They gave me $11,000, $8,000 or $9,000 for my instruments, which I could manage. I said it was almost $10,000, and $3,000 for student research assistants who would work with me. So that was amazing. I was very happy about that one. And then I get going, and next 2 years, I also started getting funds. So you definitely have to have more funds. Sometimes instruments go wrong, and then research assistants. But last time I got grant is 2019. Then the pandemic came, everything. But I kept going because I had a lot of data already, and then I could publish. And present in many conferences. But now, of course, I need another grant. That's the point. And not much, $5,000-6,000. I'm not asking much.
Thank you, Dr. Davis.
Thank you, Dr. Davis. Yeah, it's pleased to see you.
Yes.
Yeah, now the laser I bought,
That's
it
the
was,
pre-inflation laser.
it was right. It was $3,000 at that time. Okay, when I bought, but again, anything you buy, then there is customs and other things here. It is higher.
What's the duty rate for a laser?
I don't know. It depends on the size, and I don't know.
What line of the anyway?
Well, by the laser now, I saw that the same laser I bought $3,000. Now it's $4,200 now. Okay. So that's what I'm saying. I need at least $5,000 with the laser and the other costs.
They need to cut the duty on.
They should actually, because it's I'm not asking money for myself. It's not like usually researcher gets scholarship, right? Some amount from their research fund. I'm just asking money to keep going with the research. Yeah.
Are we geographically susceptible, or anyone, I guess, against major storage systems? So we have good air quality, but we also have less population and land mass
Right.
someplace. So even if we have great air quality and are doing things more right, maybe than other places, are we susceptible to having lower air quality come in because of storm systems?
Are we susceptible? I don't think so. The thing, you see that, I know locally you are not producing enough air pollution. That is true. But that transport can happen, long-range transport, and I'm sure that you know about the Saharan dust. Every year actually flow over the Bahamas, and I have shown actually in one of the paper is the high hazy condition in the Bahamas during 2020, which was called, I think the name was Godzilla or something like that. The huge dust that came over. So I think we can be happy at this point for having a nice air quality, but we have to be careful about that, and also internationally for any convention happens, we should raise the issue that air quality in other part of the world should be also like controlled, because people do a lot of things which we may suffer because of their activities.
Okay, thank you so much, Dr. Kabir.
Thank you.
Okay, up next is Dr. Welsh. I understand that she has a PowerPoint. Dr. Welsh is joining us from Oberlin College, but I understand she's returning to us, yay, in January. Okay, let me see.
Need to be able to share screen.
Yes. Yeah, let's see. Security. Oh, yeah, sure. Allow participants to share screen, and I'm going to record on my computer. Okay, take it away, Dr. Welsh.
Are you seeing the full screen, the presentation, the full screen?
Yes.
Perfect. Okay.
Are we hearing it through the microphone?
Is everyone hearing me?
Yeah.
I'll move up to the computer. Hey, good morning, everyone. I'm really pleased to be here. My name is Kristen Welsh-Anwala. I'm currently at Oberlin College, and as Dr. Owenbring said, returning to UB as of January. And the work that I'm presenting on that was within this latest issue of the International Journal of Bahamian Studies, it's entitled Grand Bahama Post-Hurricane Dorian, a comparison of freshwater in 2 primary well fields. And this is some data that arose from a BPAF project that we had published last year in the IJBS, in addition to some work that was done by our collaborators in the Technical University of Munich. And that's Anna Image, Isabella Lissel, and Arno Rain. So I'll be presenting some data from them as well. So within the Bahamas, many of you are probably aware that we have these freshwater lenses, which is essentially just the fresh water that comes from precipitation that infiltrates into the ground and then sits on top of a deeper saline water that comes from the ocean. And I've drawn a little schematic here, so my apologies for not having subtropical trees, but that was not part of the program. But this is essentially if we were to cut through and look at a profile of an island, that we have this lighter blue colored freshwater sitting on top of the seawater, and that's called the freshwater lens. So freshwater lenses are a source of drinking water for many small islands around the world. We used freshwater within New Providence and on all of the Bahamian islands. We're now moving towards desalination in many areas, particularly where we can't support that extraction of freshwater anymore. But one thing that's not well understood is how these freshwater lenses recover from catastrophic events. In particular, we're looking at Hurricane Dorian back in 2019, in which the freshwater lens was essentially, that whole supply was decimated with flooding that occurred. And so one thing we don't know is, since it's so important for our drinking water source to rely on these freshwater lenses, is how well they recover, how fast they recover, and what that process is like. So some of the data that I'm presenting here today is to help us better understand those processes. Hurricane Dorian, as we're all aware, resulted in quite catastrophic damage on Grand Bahama, as well as Abaco, although we're focusing on Grand Bahama here. So in Grand Bahama, there was more than 1 meter of precipitation, flooding up to 6.4 meters in some areas of the island. I have some satellite imagery comparing the island before flooding. I think this was taken a few days before flooding, before that hurricane. And then below, you can see some of the yellow outlines of the island and how extensive that flooding was. So that led to an complete inundation of salt water into that freshwater lens. And that can be quite damaging for those sources. This is showing just a quick schematic of wave overwash that happens in flooding. And you can see from that lighter color, and the overwash, how salt water can come down into the freshwater lens. And once that mixes, you can't get that fresh water back. You can't separate out the salt water from the fresh water. So you have to wait until precipitation eventually falls, and that there's enough that falls that it can create a new freshwater lens. And fresh water, for anyone who's not aware, is less dense than salt water. And that's why the fresh water, when it comes from the rain, it sits on top of the deeper salt water. So it takes a lot of time for that to recover. So we knew that there were limited data of water characteristics before and after extreme events. And we wanted to help contribute to that body of knowledge and understanding how the freshwater lenses in Grand Bahama are recovering. So we need to collect more data to understand the hydrologic processes that are governing what's happening in groundwater and how they recover. So our goal for this study was to investigate the potential for natural recovery of freshwater lenses in the Bahamas. And some of the questions that we were asking is what factors influence salinity in the freshwater lenses? So trying to understand even before we have inundation of that, how does that freshwater develop, and the thickness of that changes dramatically across landscapes. And I'll show in the next slide a picture of the freshwater lens in Grand Bahama. Understanding the effect of tides on groundwater as well. So we don't have a lot of published information. We know that the water, the subsurface water, so the groundwater, is connected to the ocean water, and particularly when we're looking at really small islands like across the archipelago of the Bahamas. But we don't really have well-published information. There is some information that exists, but not well-published information on how the tides are affecting groundwater levels. And then also understanding how similar two well fields were the primary source of drinking water for Grand Bahamians, understanding the processes, the hydrologic processes happening there. So this map is showing just the central portions of Grand Bahama. And Wellfield 1 is the one that is to the southwest. Wellfield 6 is to the northeast there. And this is overlain. We're showing the MW stands for monitoring wells. So those are the monitoring wells that we use to look at groundwater levels and some various water quality characteristics. And those are for this project. So we have monitoring wells. We're primarily focusing within the study on Wellfield 1 and Wellfield 6. It does show that there's two smaller well fields in the western portion, Wellfields 3 and 4, but we're really looking at 1 and 6 here. So those are overlain over the freshwater lens and the contours of the freshwater lens and the thickness of that. So the pink colors are where we have less depth of freshwater, which is approximately 10 feet, for the darker pink colors, moving up to the yellow in the center, where we have about 50 feet of freshwater. So if you remember back to that schematic I showed before, the profile that we have, that lens forming, it's deeper in the center, you know that. And as we get closer to the coastal region where we have more influence from the ocean there, then it gets thinner. So within this study, we looked at groundwater levels, and we looked at water quality through electrical conductivity. So electrical conductivity is highly related to salinity, and it's essentially a measure of the ability of water the ions that are dissolved, and the ability to conduct an electrical current. But essentially, when we're looking at that, in this case, we're looking at what that there is such a relation with salinity. So we're looking at salinity there and the temperature of water. And we are trying to calculate what is the time lag between fluctuations in the tide at the coastal region and how the groundwater is responding to that. So looking at high tide and low tide, what those times are, and then tracking over time electrical conductivity, and you can see that change. I'll show that in my next slide. And so we're looking at changes in salinity essentially over time. And when you see that peak, we know that the tide has essentially reached that monitoring well. So we're just calculating tidal lags as the difference between high and low tide, and then when the groundwater responds to that. And then also looking at stable isotopes in water, and sampling precipitation and groundwater to investigate how similar they are. So I don't want to get too much into the details of stable isotopes, but it's essentially looking at hydrogen and oxygen atoms within water. So we know water is made up of hydrogen and oxygen, and we are looking at the isotopes of oxygen, which is oxygen 18 and hydrogen 2, or deuterium. And these naturally occur, but based on any water body anywhere in the world, we'll see variations in that. And that's how we can characterize that relationship, or the ratio between oxygen 18 and oxygen 16, which is the more common isotope that we see in water, and the ratio of hydrogen 2 to hydrogen 1. We can calculate those ratios and sort of gain like a signature that what we would call signature of the water body, where it would be very characteristic. So if I were to drink water from New Providence, for example, my body would take on those isotopes and it would represent the water that I'm drinking in New Providence. In Grand Bahama or any other island might have a slightly different signature because there's different processes that are happening to change those ratios. So we're looking at just within Grand Bahama on those two well fields to see how similar they are to each other and how similar to rain. So I'm first going to focus on this question of tidal lag. I mentioned that is measuring the time between the peak of the coastal tide and groundwater. So this equation that I have over here is just simply the T sub 0 is the time of high tide or low tide, whatever hour that occurs. And the T on the right is the peak time in groundwater. And so we're calculating what is the difference between that. And you can see this on the slide here. We're looking at the tides in blue. So that's the ocean tide, just the height in meters or that change from normal or baseline. And you can see it going up and down. And then the orange line is electrical conductivity in groundwater. I mentioned before that that is related to salinity. So essentially we're looking at as the tides get higher, we see a peak in electrical conductivity, or essentially that we're seeing more salts getting into the water, and that peaks very similar, looking like the height of the tides. So we know that the tides are arriving in the groundwater and that they are impacting it. And we wanted to know how long does that take approximately within the different well fields that we were looking at. And we found an average tidal lag of 2.5 hours. So it takes about 2.5 hours from the coast when we are at high tide, that high tide water to reach internally to get into the groundwater. There was a range across the island throughout the well fields, anywhere from 1 hour to 5 hours, but the average was about 2.5 hours. And for isotopes, I mentioned that we're looking essentially at what the signature of the water samples are. And if you plot your hydrogen versus oxygen isotopes on a graph anywhere in the world, you should get this this ratio essentially that we're looking like a straight regression line. So this is what we would expect to see. Waters at the very bottom, I list the global meteoric water line. So that's if we took every water sample in the world between rain. This was done with rain, precipitation. And this was a very famous study done in 1961. And so this author, Craig, determined the global meteoric water line, looking at the average of all water samples around the world, and found that there's a relationship if you multiply your ratio of oxygen 18 atoms times 10 and times 8, and you add 10 and you get your hydrogen 2. So that's the regression line for the global average. And that varies a little bit for every region on Earth. And we don't have a lot of data within the Bahamas. I've been collecting some in New Providence and some in Grand Bahama. So we're trying to gather baseline information to see how similar that is just for all rain samples throughout the Bahamas, but also if that differs from island to island. I would expect that it would based on climate processes. But for this study in just a short period of time, we collected some samples and we found the equation to be 8.2 times oxygen 18 plus 12.2. So somewhat similar. The blue samples are precipitation on this chart. And in general, according to whatever processes are happening, you'll see very different ratios happening. If you have a really large storm event versus if you have a small event, and it's based on a lot of complicated conditions within meteorology, like the pressure, the time of the storm, where the storm originated, how long it's been raining. So there's always going to be some variation along this line. We expect groundwater to be a bit more stable, and that's why we see those dots, the orange and the purple dots, clumping together, because precipitation is happening on the order of minutes to hours, whereas groundwater sits there for many, many years. And so it has a lot of mixing, and the isotope ratios of that tend to be more stable. So we can see that they plotted on the local meteoric water line. So looking at all the samples, they were, as we would expect, to plot very similarly along that line. But there is a bit of this clumping of the well field 6, those purple samples, and well field 1. So they are separated a bit and have a little bit of a distinct signature that we saw from this. So we would be interested to collect even more samples to see if this continues. But based on these preliminary data, it seems like they have some distinct a slightly distinct signature, which I find really interesting because Wellfield 1, if you saw on the map before, Wellfield 1 and Wellfield 6 are relatively close together. So rain events that are happening would fall, since rain is the main influence into the groundwater, we would expect a very similar signature since those well fields are so close together. So some of the key findings that we came up with from this study was that there is a significant tidal influence on groundwater. And I don't think this information has been well documented, as I said, within the Bahamas, but the groundwater levels do rise and fall with the tides, and also the salinity is changing of the groundwater over time at certain depths, depending where we're measuring because of that groundwater. So because there's such a connection between the tides and groundwater, it makes it more complicated when we're looking at natural recovery of these freshwater lenses that are very, very, they're very critical systems in that you have some destruction like what happened in Hurricane Dorian that decimates the freshwater lens, and it takes a significant amount of time for that to recover. Excuse me. We found that the top of the freshwater lens and the center of the freshwater lens was less responsive to that tidal influence, which makes sense because the center is going to be more thick. So it has a deeper, we saw those, the maps of the freshwater lens thickness, it's more deep in the center. And so there's less, the top of the freshwater lens and the center of it will have less response to the tides. And we saw more of an effect closer to the mixing zone between the freshwater and the saline water underneath. So one interesting thing that was a bit different than what we've seen in other areas is that you would tend to observe an increase in your tidal lag as you move away from the coast. And so that just means that it takes more time for the tide to reach into, as it moves with greater distance and moves into the center of the island, it would take more time. Intuitively, that makes sense if we're thinking about coastal regions versus areas within the center of the island, that it is going to take more time for the tide to reach through that land. We did not see this within Grand Bahama. So there was a range between 1 and 5 hours, but that wasn't necessarily that the wells that were in the center of the island had that greater tidal lag. So this relationship was not seen as closely here. We did see a signature, as I showed you, of the stable isotopes in Grand Bahama, similar to the global average, but the well fields had slightly different signatures, as I mentioned on the previous slide. And this could be due to microclimate factors. We know that microclimates happen anywhere we are in the Bahamas, that, it can be raining on one island and not in another. It can be raining on the west end of New Providence and not on the east end. There's a lot of variation just over very small areas of land. So it could be because of those, the microclimates that's causing this different signature, because precipitation will have a different signature according to that, whatever climate processes are happening. It could also just be the influence of the Grand Lucayan waterway, which I don't have a map right here, but in the beginning, if you may have seen it or may be aware that the Grand Lucayan waterway runs right between Wellfield 1 and Wellfield 6, essentially separating those two. So that could also have an influence on the isotopic signature. So those were some of our main findings. I'm happy to answer any questions. I just want to acknowledge that part of the funds that came from this were from the Bahamas Protected Area Fund and the Caribbean Biodiversity Fund. And I'd like to thank a few individuals at UB and the Grand Bahama Utility Company, ISRAID, and Davies Associates as well. Thank you very much.
Thank you very much, Dr. Welsh. Any questions from the audience? Yes, Dr. Kabir.
Dr. Welsh, I have a question. You said that there is no increase in tidal lag in Grand Bahama. What was the explanation why there was not increase in tidal lag in Grand Bahama?
Did you hear that, Dr. Welsh?
Dr. Umbring, could you repeat that? I heard part of it.
The question is, do we have an explanation for why there was not an increase in tidal lag in Grand Bahama further away from the shore?
From the shore, from the coast. What was the
I think there's some theories, but we're not entirely certain. So it could be, I'm not entirely, my colleague had done part of this research and is more of an expert on that, but and so I'm not sure with the other studies that have been done around the world if the comparison of the size of the island and if that had any influence that perhaps Grand Bahama, looking at the size of the island of Grand Bahama, if that was smaller than some that had been studied before. If that is not the factor, then it could be just due to the soils and the subsurface underneath, that there's just such high connectivity in some areas, or even the Grand Lucayan waterway again could have an impact where that's creating more access to water on all sides. So I don't know if that was taken into account, because now we're looking not just at how close the coast on the north and south side of Grand Bahama, but also you now have this major waterway cutting through, so that could potentially influence it as well.
Yes. Dr. Curling. Yes, sorry. Yeah, okay.
Judging from the impact of the Grand Lucayan waterway on the lenses, is that a good idea?
The question was, judging the impact of the Grand Lucayan waterway on the lenses, would that be a good idea?
Yes, I think
Was that a
that's
good idea?
something that. Sorry, what was the last part?
Was that a good idea? Sorry.
Yeah, I think that needs to be investigated even more. So I pulled up the map right here, and that you can see I'm not sure how well you can see that on your screen over there, but there's an arrow with the text in the southern side of the island that shows the Grand Lucayan waterway that essentially cuts through that. So it's impacted. That used to be one large lens across from Wellfields 1 to Wellfield 6, and that essentially just introduced all this saline water into that. And so that definitely impacts the hydrology and the groundwater systems and what's happening. So I think that needs to be investigated even more. And I think that will have dramatic impact on the recovery of these freshwater lenses that were already cut down in size, but will take probably more time because there's increased access essentially to ocean water now through that waterway.
I've never been to Grand Bahama, so is the Grand Lucayan waterway like a river? Is it an inlet, or like a canal or something like that? Or,
Yeah, essentially a canal that now cuts
Okay.
to the island, man-made.
Oh, man-made canal. Okay.
Mhm.
I see.
And also, if I could add something, Dr. Ombre,
Yes.
I just, actually, I don't know if I have pictures here. I do have pictures here. I didn't bring this up, but if you can see on the top here, we have Wellfield 1, which is the recovery of that the damage was not quite as extensive in Wellfield 1 versus Wellfield 6. If you see that on the bottom, where it looks like now all of those Bahamian pine trees are like toothpicks on the landscape. It's a very barren landscape, and that really impacted the forest ecosystem. So we see very dramatic responses in both of these well fields. So it's interesting, and it will be interesting over time to see how the two recover with more time.
Okay. Do we have any other questions for Dr. Welsh? Okay, well, thank you so much to everyone for coming today. It was very interesting. Yes, we have 5 more pieces of very interesting Bahamian research. As I said, yeah, we are really excited to get all this really high quality natural science research. In particular, it seems that there's a lot of science research involving the Bahamas that Bahamian institutions have and people have no foothold in whatsoever. So I think it's really great for us to be participating in these discussions. Yeah, so like Dr. Gustav got his students involved, as did Dr. Kabir. And I know some students, some UB students were involved in this greater research project, right? Right, Dr. Welsh, yes? Yeah. So anyway, that's all great. And so I thank you all so much for coming, and I hope you enjoy